I was looking at it, close. I saw it. I saw the lights. No, I saw that.
That's a contraption.
New rocks, yeah, I can't see the back. Well, you don't work, but it doesn't. What time you gonna bought? Yeah, you got a superior. He's trying to write a picture, and it was like, oh, I'm not there and looking for it and stacks, and it's a weird thing. Heavens above.
Always, you got any pictures?
Not yet found, but it's only this on the moonrise.
Yeah.
Oh, you haven't gotten it. Is it there?
Looks like that's going.
Everything with the phone, it was all kinds.
Somebody just sabotaged the
Lines
GPS.
itself, it would go to any, show like, I'm looking there, go, okay, this is my backyard, I know we're going that fast. It was takes the west.
But you put me up.
I mean, it was probably 30 degrees off.
According to your, I pretty much know where season is.
Hey Terry, I can see you on Zoom. Can you see the screen? Does it show our splash screen? You can just give me a thumbs up. Good.
Yeah.
Deal. Awesome. Thank you.
Yeah.
7 years away.
I know.
Everything looks good.
I was looking around for pictures and it's like, oh, that was 7 years ago.
No, Jupiter's are. We were looking at Saturn Friday night, and Saturn not that great right
No, I
now.
mean, Monday night was Monday was the occultation, but I thought I would see the dragon age. Monday night happened. Yeah, right. And that's, the thing is, it's Italian is. Several bits.
Question, and radio question. So what's Short Mountain now, the big overalls is, moved on.
Well, George.
George.
You sit down the driveway.
I can sit on the deck and
Old guy, fat guy, bald guy, glasses.
all of them look that way.
Retired scientists.
They all look that way.
Same thing, but
I don't know. Think, well, who's taking it was really just a sophisticated toy,
the president.
you know, but it works of the boy.
Oh, Peter.
Like a boy. B.O.Y., big overall son.
What?
He can't take care of
Just
it.
what this?
Really?
Yeah.
I didn't think she was a large.
Sophisticated. Yeah.
Okay.
Too much, man.
Okay.
I got so little discussing politics.
Because it gets on the air all the time.
Yeah, it gets on. Harry just turned 28. Yeah. Yeah, he's but yeah. So, and there's other relatives too.
Okay, well, all we ever did was, boy, and she did,
Well, Debbie was always with them. It's a neat. She's that woman that sat there.
I'll take your word for it, I don't remember a woman.
If you don't remember, it's all right. That's cool. That's cool. But that's that's cool. That's cool. How these guys do test. I can't get nothing. Unfortunately, it's not quite common.
Yeah, and the other question, why did they move the Cedar Living back in?
A week after the was it Huntsville? It's always the week after Huntsville or on the last rainy Saturday of the last rainy weekend of August.
Which is, they moved,
Except for climate change.
they moved it a week, didn't they, this year?
What? No, it's always a week after Huntsville. You didn't go to Huntsville?
I haven't been husband 3-4 years.
Well, you're like halfway there from here.
I know. I don't need anything, so I'm good. I mean, I don't know, go down there and walk around for 30 minutes and go back home.
I go down there when I didn't go this time, but I go down there for lectures. They had Dr. Bateman, the lightning professor, and everything talked about.
And I do want to
Picture
I do
station.
want to go to Dayton this year, just to say I've gone to the new place.
Yeah.
As I've never been to the new place, I've always been to the.
I have
toilet
toilet.
thing.
Well, that was classic. I mean, it was not even be.
Oh, yeah.
Crazy.
I was there the year that they
Yeah,
had the toilets back there.
Yeah.
I was there the year all the toilets back there.
Think that most years.
Oh, no, I mean, this was amazing. This was a road thing.
Well, think about it. Now, the new place is a nice place and convenient. Yeah. I met people that do it there and it looks good.
Man, I was at the old fairgrounds at the city.
Zenith?
Place in the fairground.
Well, I'm not quite sure I have a relation. I guess it is. One thing about Zenith is everything is 1974. In Zenith, because they're great for to go out break with it.
Oh, yeah. Yeah, actually, I was at Dayton a year after the tornado outbreak.
Luckily, I was
They were still talking.
Zenith, yeah. What? But I don't know, I really want to find somebody over there. Who's not a lot up there. Zenith is a really county, Ohio. They got a perfect county airport. And it's only about a mile.
Come back to us.
I came up there when I met you, like, up next to that.
Oh, there we go.
Well, you came once.
Well, you might do that. Before True Valley, you might could have. I don't know, but, it was. I mean, we got treated totally nice. They were having a barbecue and everything, and we just came back. I'll be smart.
I'll give it a few more minutes before we officially start up here.
Anyway, yeah, look, they're having a nice day.
Sounds like a nice deal.
It's about a half-mile strip, about like 24. Very similar.
Oh. You see my links I sent you? Oh, yeah, but no, it's not. Very good. Very nice. Do you see what the screen's doing up there?
Yeah.
Yeah,
It always does that.
Yeah.
I started cussing now. You always start cussing, just test.
Bud is in the house, all right.
That's pretty cool.
yeah. So I turned it on for my classes, and that way even the kids at the back can understand what I'm saying. So it works out well. It's ridiculous how sensitive these things are, and then you go, oh, that's how Alexa and Siri do their thing, because it picks up conversations from all the way in the back there. So it's pretty impressive.
I've been told. That is a weird thing that timing is wrong. I wasn't complaining about it, I just wanted to last block that I left it. Mysterious container. So where's the next slide? I mean, he's not.
Yep. Every time I come on the hill, I keep started. Well, not something. Good judgment.
Like this.
You never found it. No, I'm also amazing.
Right.
Guard radio.
Guard.
I think there's they have gargoyles too.
You mean like it's summer around here?
Yeah, you lost my road. Nobody.
Yeah, even in the summer, even in the summer.
Every time I drive.
It's probably best you cut that audio off before I started saying TATP.
See if that works. I'll see it. Well, sort of. All right, we'll go and get started up today. Turn my camera on. Sorry, everybody on Zoom. You get to see my face for a minute. Let's see. There we go. All right. Hi, everybody. Welcome to our August member meeting. I'm not sure how we're already in August. It's pretty wild. I'm Tom Beckerman, current president of BSAS. Welcome, everybody, especially new members, guests. Any new members and guests here today? Nice. Oh, look at that. We got a full house of everybody. This is fantastic. And as you said, you're Brian. So welcome to our member meeting. Today we're going to walk through some of the things that the club's been doing in terms of outreach and talk about upcoming activities. Our guest speaker, Theo, hopefully is on our way. If not, I'll do a little song and dance up here, and then it'll be a short meeting today, but I imagine she'll be here shortly. I usually put up something, related to the date, but this came up in my memories today, August 21st, 2017. So 7 years ago already, it was that first eclipse. It doesn't seem that long. That was actually whenever I joined. I joined right before the eclipse for the free set of glasses that they gave us. So that's where I was at as a grad student. So still got them. Yeah. Those things, fine, as long as you hold them up and don't see any light through them, you're still good for a bit. What they say, 10 years is the expiration in theory on them. But so this is one of my shots from the 2017 eclipse. It's amazing whenever I was going through looking at my eclipse photos from this last one. This is the only image I ever processed of my 2017 eclipse. So I have a ton of images still to go through, but this one didn't turn out too bad. Let's see. Oh, that's why. All right. So getting started up today. PowerPoint didn't want to go. We'll go ahead and get the meeting called to order. Hopefully you guys had a chance to read the minutes sent out in the local news or in the monthly newsletter. Anybody have any questions of the happenings from last board meeting as well as the last member meeting? Bless you. All right, moving right along.
Oh, I have a question.
Yeah.
When you do it and we do it on Zoom from home, do we get logged in as showing up? Or something else?
We have I can look on here and see who's been here, right? And it goes into our, we had 25 people. So yeah, exactly. Right. Yeah. So it's that plus whoever's online. So because you're here in spirit, if not a face behind a picture on your Zoom screen.
We're out here. We're out here.
Yep, they're out there. Yeah. That was Chuck, I believe.
Yeah.
As far as members, Keith's not here. I took a look today. We're at 201 members, up 6 from last month. So it's good to see the hobby growing. Again, everybody's welcome. We love sharing what we do. Hopefully new members here and guests will get something out of our meetings and really feel a good connection with this hobby. Let's see. Our treasurer is the one that's normally that's going to give us a talk today, but I have our membership or our board meeting numbers. Our truest bank balance is $8,011.91. PayPal is $452. And we have cash of $60. And as far as business goes, we paid out for our yearly Zoom account, our monthly Zoom account, I believe. And some expenses coming up are some things that we're doing to update some of the equipment that we have for use by the community, by our members. All right, cool. Theo just parked. All right. Moving along. Speaking of equipment, we do have a loaner program. It's one of the perks for for members of the club. It's free. You don't have to pay to check things out. Typically tell you before you buy a scope, borrow, right? So you can make sure you can get the scope that you want. I currently have one of these bad boys, an 8-incher available for borrowing. If anybody wants to borrow it, you can see what it takes to lug around an 8-inch Dob. If you realize that you don't want to lug around an 8-inch Dob, it's best to borrow before buy. And so you can see if you'd like it, see if you'd use it. We also have a variety of smaller scopes available to borrow. The list is on our Google group. It's at the top. There's a link to that on the website. If you have a scope, let us know how it's going. I know I've checked out a few of them lately. If you've had one for a while, let us know how it's going as well. We'd like to hear about your adventures, see what you're doing with it. Let us know what you're seeing. Also with that, sometimes telescopes can be frustrating. If there's anything we can help with, reach out to us and we can walk you through what we know and see if we can get you lined up and seeing what you're after. We also have star parties that we host monthly for the public. We also have the private star parties, and we'd love to see you bring a scope out to either share with the community or use yourself, and we can help you that way too. All right. Hi, Theo. So you can find us at bsasnashville.com. This is a screenshot from last night, I believe, with our next member meeting, a little blurb about our talk tonight. We have some information on star parties and upcoming star parties. August 21st. So this is our next public star party out at Bowie. We also have on here our beautiful hatch print that we had specially made for our 90th anniversary, which was a couple years back now. It doesn't seem that far back. But those are available if you're interested in one. Theo back there has it holding up by lightsaber. And they're 20, is that right? 20 in hand today, or if you want it shipped to you for some reason, like if you're not here, it's 25 because she sends it in a nice little container. So we have those available. One other thing I always like to point out on the BSAS Nashville website is we have this clear sky chart, tells you the quality of the sky. The darker, the better. Right, that's what we go after. So as of last night, looked like Friday maybe pretty decent in terms of cloud cover. Transparency, a little light, but not too bad. Also on our website, we have on the left below our menu, we have Facebook link, X link, which used to be Twitter, and Instagram. So you can find our socials there. And so those social buttons will take you to Facebook site where we're posting things, pictures from our members, updates on stories, sharing stories from local sites or national sites that have just interesting things about space and science. This image is taken by Theo of our blue sturgeon supermoon. On the left, nice and up in the sky. On the right, being squished. So I always love that image too. And so beautiful pictures. Theo, thank you for sharing. On X, we also cross-post a lot of things. This is a image or a post from the European Space Agency. I went back a couple posts because I felt like it was kind of fit into the theme of this month's topic because we had the big supermoon a couple days ago, and then I'll talk to you a little bit about it, but the International Observe the Moon Night or Observe the Moon Day, whatever, is coming up shortly. And so we'll talk about that. And so here is a post about music for the moon on Spotify. So you can find a link for that to sit down and, just enjoy yourself. On Instagram, pictures posted up. Got some pictures from of the sun, nice little picture of the observatory, and then an update on star parties that show up through here. And so you can find us on all those social media pages. We have a member group, or we run our groups, our communications through Google Groups. If it's a private site that we have for members only, if you're a member and don't have access to it, please email us at info@bsasnashville.com and we can get you set up and get you access to it. The Google group is great for sharing information like images, star parties, just general questions about what we're seeing, what's out, who's going to this star party and things like that. It serves as a great tool for just communication. You can have it set up where whenever somebody posts, it automatically emails you. So you don't necessarily need to log in, but you'll stay in the touch with the people in the club. So it's a pretty cool opportunity and a good way to stay in touch with the people that have the same interests. This is a post by Theo on the 10th, so a little bit ago. But here you can see our little blaze star, not yet blazing. A friend of mine said that he expects it middle of next month, but I don't know. I saw somewhere where it said could go all the way to 2026, so I don't know. But it'll be interesting to kind of keep an eye on it. I believe the is it I can't remember who has it, but they have the certificate for observations of before and after. And so it's a little project that you can do.
Well, keep in mind, it's already happened several times.
Yeah,
We just haven't seen them yet.
yeah, that's accurate. We run our club through the Night Sky Network. It's a pretty good clearinghouse for us where we can control our rosters and put up our club events. That's how the emails get to you through the Night Sky Network. And so if you haven't become a member yet and you're interested in becoming a member, you have to go through the Night Sky Network and create an account. It's a really good resource for materials. You can see that here we have September's Sky Notes talking about moons as well, right? So kind of on theme, not just the moon that we have on Earth, but some of the really cool pictures from Saturn and Jupiter's moons, kind of getting ready to celebrate the International Observe the Moon Night. And so it's a pretty cool article. Then they also have things that you can look for in the sky. So if you're going to a star party and you're like, what am I going to talk about today? Well, they give us some good sky notes. And if you've never taken a look at doubles or double doubles in a telescope before, it's really cool. And so showing the public just something as simple as the two stars or one star has a different color than the other, it can be pretty breathtaking. And so here you can see a host of doubles or the great double here in Lyra. And so it gives ideas of things that you can show or things that you can even look at on your own. They also have these maps of things to potentially look at and find. Here they're talking about maybe just grabbing binoculars and taking a look at this area here between Antares and Altair and just kind of observing star cluster and nebula. And if you've ever grabbed some binoculars and just kind of sat back and let your eyes adjust and just start working your way up that way, it's quite a sight because be amazed at what you can pull out. And so it's really cool. It's another cool thing that the Night Sky Network has of these monthly sky maps. In terms of the club, we've had a few events go on since the last time we met for club meeting. We had a private star party on the 3rd at Water Valley. Did anybody attend that? Yeah. Was anybody else out there? Yeah. Did you get some good seeing?
Yeah, there was a couple of Christians as well that night.
Oh, that's cool. Awesome. And so for members, we have access to the Natchez Trace Parkway, which is really cool. We get out there we have access from dusk to dawn. And so you can get out there and not be rousted by the National Park Police or the sheriff. And so it's a pretty good thing that we have. On August 10th, we had a public star party at Warner Park. If I remember, well attended. Was that the proper word? We had, I think I heard 10 scopes. Does that sound correct, Theo? Yeah. And so that's always a fun place to host. And then Chuck Schlim posted about the full moon picking party. Him and Tony set up there, and it sounded like they had a pretty good time. So thank you, Chuck and Tony, for doing that for us. It's always good seeing members doing their outreach. upcoming things for just the general events and outreach. We have a private star party planned for the 31st, so 10 days from now. I always like to kind of put this up and start taking a look at. We see that the sunsets are starting to get a little bit earlier and earlier again. So if you like the night sky, it's perfect, right? Because you get a little bit more observing power. What that also means, though, is that for our star parties, especially the public star parties, they start beginning a little bit earlier, and so we have to get out and set up earlier as well. So we have the private star party at mile marker 435.3, which is about I think it's about 2 miles past the big bridge on the Natchez Trace, and it's off to the left. It's a little pull off, and so it's not a bad site. If you do go out there, make sure everybody out there has access to a permit. You don't need the paper copy, but you should have access to it on the phone. You can have a paper copy, but with the humidity and dew, that kind of sets up those paper copies turn to pulp relatively quick. So I keep mine on my phone, and that's in case the trooper stops you and then says, "What are you doing?" You can pull out the permit and say, "I have this," and in theory, it should be okay. On September 7th, we have a public star party at Bowie Nature Park out in Fairview, starting at 7:30. Bring your telescopes if you're interested. If you have a club telescope, we'd love to see you out there. It's always a good time and usually a pretty good showing. And then coming up next month, less than a month away, is on September 14th is International Observe the Moon Night. And I don't think we have anything officially planned for it.
Shelby had asked me, they were doing their newsletter and they go, we're not there until December.
Yeah.
I said, well, if you want, we could probably do the International Observe the Moon Night because the city lights don't matter for them.
Yeah, 100%. Well, keep us in the loop. Send something out on Google Groups.
That's an easy thing. I mean, some of it.
Yeah, it's easy to find too. You don't have to.
No, I'd be at the nature center.
Yeah.
Either way, in September, it's not going to be snowing and
Right.
That doesn't happen in Nashville. What are you talking?
that's the only time.
only on Star Party nights. Yeah. So
Hey,
as I
Tom,
was doing some
Hey, Tom? This is
yeah.
Chuck. I'm going to be exhibiting at the U.S. Space and Rocket Center on the 14th for International Observe the Moon Night. They bring some telescopes outside, and then I'm going to have my space exhibit inside.
Now you're just showing off.
You betcha.
Tony. Yeah. Well, that's good. Thank you, Chuck, for doing that. Let us know how that event goes as well. As I was looking around on the Night Sky Network, they had a little article about International Observe the Moon Night, and so I found this flyer that's put up by NASA. NASA's really pushing this, and so I'll run through some things. They're talking about how to get people out and interested in things that you can do in order to interact with this event. If you go to this website, moon.nasa.gov/observe, it takes you to a pretty cool website that they've put up for International Observe the Moon Night. And I wanted to highlight two things because I get interested in things fairly easily. It drives my wife nuts. Over here in the resources, if you click on this activities area, it takes you to a list of things. But these two drew my interest. And so Citizen Science Project, right? That's science that we can do. We can contribute to researchers and what they're after. If anybody likes to play those games of spot the difference, this is where you can do that. And so this activity through Citizen Science is looking at new craters and new impact sites. And so it'll put up one image and another image, and you look and see what's different, right? And so it's a fun little game. On here, whenever you click on the examples tab, it brings up two sets of examples. This is the Apollo 14 landing site. And so this was an image taken before Apollo. This is the image after, and you can see the lander, you can see footprints, right? And so it's actually a cool piece of history right there that you can kind of see from their images. And so obviously, well, we can spot those differences. here's another image that they set up. For example, this happened in 2015. And so this image was, I think, 3 months before this image. And so you can see not there and there, right? And so if you're doing this imaging, or you're analyzing these imaging images, you could highlight that and send it in, and it'll be verified by whoever. And so as somebody who's done research in my life, not in this realm, but in the biology realm, it's always great to have hands-on to help out with some of these tasks that, you know, it takes a while to comb through all this data. And so it's something that if you're interested in helping out the scientific community, I'm sure that they'd love that. And so you can get to there from that moon website, or from the NASA's moon website. And then this is another thing, Astronomical League. That's what I was missing. They're setting up an observing challenge for International Moon Night. But they're giving you a week to complete it. So the September 14th through the 21st, they ask that you sketch or take a picture of your moon. And so I do a lot of imaging, so I'll probably take my pictures. And then they're asking you to identify and label the 10 lunar seeds. Right. And so you can go through and highlight them, color them, point them, and then you submit that in. And I don't know if they're going to give a certificate, but it's a cool little observing program to get you more familiar with the moon and get you looking up. So it's a pretty cool set of activities, you know, centered around the moon itself. And so I thought those were pretty cool to highlight. Coming up in the night sky, we have a few things. We're already here on, you know, towards the 26th and then into September again somehow. I have a lot of you know, things coming together: the moon, Mars, Jupiter, and Aldebaran. That seems like it'll be a pretty interesting view in the sky. And then here you have the moon and Mercury, which I always like it when Mercury is close to something, because it makes it so much easier to find. And if you go to we really like Stellarium. It's free. It's, you know, you can put it on your laptop, but they also have a website that you can use that you don't have to download their material, their program. So here's stellarium-web.org. This is that conjunction of the moon, Jupiter, Mars, and Aldebaran. So within, you know, this is a 50 degree view, right? So it'd usually be a bit bigger, but here you can see the moon. And so it's actually pretty good grouping of those. So that'd be a cool picture. And then here is what I was talking about with Mercury, and check out the sliver of the moon. And so this is at 5:30 in the morning, if you're up, right? That's the thing about, you know, Mercury, is you got to catch it somewhere near the sun. So you're either up early or trying to get there right as sun sets. So but this gives you at least a beacon so you can find Mercury. So some cool things coming up in the sky. Theo's going to come up and give us a talk here shortly. Well, I have one more slide. I just wanted to give a plug for next month. We have Dr. Jeff Gray, is a friend of mine. He works at JPL and the Night Sky Network. He's an outreach coordinator. He'll be joining us over Zoom next month. And so our next member meeting will be the 18th here in person or over Zoom and on YouTube, as long as I remember to hit that button. So that's what we have. Are there any questions about club business at this time?
Was there anyone planning on going up to ticket
You mean for the moon?
or anything?
I don't know. I haven't heard anything.
They did finally post
Did they?
the stuff for the weekend in October.
Okay.
Yeah, it's the 4th through the 6th.
Okay. Well, we'll start sending out information on that. So it's October 4th through 6th. Okay. So for those that don't know, we try and get up there about once a year for some sort of collected event with them. Yeah.
It's a weekend, 2 nights, $75 for your lodging.
Yeah.
I think you bring your own food.
Okay, gotcha. Yeah, so they have a group campsite, and behind the group campsite, they have this big field that doesn't have access, or kind of clears you off from the roads quite a bit. And so it's a really good place to view. When you go up there, they have bunkhouses that they allow us to stay at for really cheap, $75 for it's 2 nights, right? And so they give us access to a meeting hall, as well as their kitchen, which is amazing. And so it sounds like we're bringing our own food this time, but still you'd have access to things to cook and stuff like that. If you haven't been out to Pickett, it's Tennessee's first dark side approved site, or dark sky approved site. And the skies out there are beautiful, especially compared to what we see from looking up in Nashville and the suburbs here. So
Saying something's wrong with our cars.
depends on if your eyes are open. I'm sure we'll post more about that on the Google groups, and we'll talk more about it at our next member meeting. We'll get more information out there. So thank you for letting us know about that. All right, Theo, you got a thumb drive or anything you want to come up, or
Do I need to put it on a thumb drive?
you didn't send me anything?
Oh, I sent you, well, I sent you an email, and hopefully an invitation to the drive.
All right, let me see if I can find it. Please stay tuned.
Let's see who's faster.
Talk amongst yourself. Well, I'm gonna have to open my email, so this could take a minute. And of course, it's updating.
This is my second presentation. Done about 7 hours of driving, so
Where'd you go?
I was addressing the gardening club at Fairfield Glade. And we talked about life pollution. And then I had lunch with the ranger at the OBED, Wild.
I know that constellation, that's albatross. Or something like that.
Or something.
Sounds like a good day.
It was a good day. I went to the Lily Bluff Overlook to take a look and see. That's where they have their public programs. And it's a little bit of a drive into the countryside, but you're overlooking.
Someone talking?
Yeah, Theo's back there.
Clear Creek come together. You're up high on a bluff, and you have a really broad view, and it's pretty good dark. So it's a nice place. He mentioned that, unlike the Natchez Trace, you do not need a permit. You can come out there anytime you want to.
Step over all the dead bodies, right?
You do have to walk about a quarter mile from the parking lot to the overlook. It's a really nice, wide, smooth trail, but it is a short walk.
Well, that is up there near Wilder and Hagu, you know. and
It's,
Jim Campbell.
it's not super far from Wilder's a more exciting drive.
Exciting, lots of.
I don't know if I'd ever heard any of those.
What's the name of that overlook again?
Lily Bluff.
Theo, can I interrupt you?
Yeah.
I don't know how many other deaf people are here, but up there facing another direction, you can't hear it.
Okay, so I'll be up there.
Oh, good, okay.
We're trying to find her slideshow. I got the email. It's just waiting to open now.
That's the thing, speak up. Now I feel-
That's quite all right. Come on.
Until she gets ready, I'll tell you a little anecdote. Several years ago, we had a meeting at the museum. It used to be Cumberland Science, what they call it, Discovery or Adventure. And a real interesting lady from Huntsville with NASA or some other big hoity-toity thing gave a talk without a microphone. I didn't hear a damn thing. I'm very fluent in French. And afterwards, I said to the museum person, I said, you know, this is a group of people, several of which are elderly, and several of which have hearing aids, couldn't hear a darn thing. Why don't you all provide a microphone? And the young lady said, oh, we did. And the speaker said, oh, she didn't need it. And I said, well, anytime you have speakers, remind them that there are a lot of deaf people. And then I went and politely, discreetly told the presenter, you know, half the people here couldn't hear what you said, including me. I'm really sorry, missed it, would have loved to have heard, but use the microphone. So at that point, I said, I'm not gonna put up with this. So next time I'm gonna speak up when I go to a public meeting now. I might make an ass of myself, but I was that already. I just say,
Well, we all know our place, right?
okay,
I got it,
but
Theo.
sermon.
Well, you got a good point, and you know, I'm wondering, how many people here have a smartphone that does not pick up FM radio?
It does not pick up what?
It will not pick up FM broadcast radio.
Yeah.
Because you can take here and whoever's presenting and use the little wireless FM mic. The people who need to could, you could have a little transmitter on it, wireless FM, and you could listen on the phone.
Well, I'm lucky, my hearing aids are Bluetooth enabled. And so for phone calls, it goes through the phone.
Chuck, can you see Theo's presentation?
I can.
Awesome.
Transit tail.
All right, so there's that laser pointer if you want it. Top of the laser.
Glad you're gonna
Then
talk
left,
about
right,
that
if you
book,
want.
that's
Got
a
it.
great book.
This is a great book. That's my signed copy too, so.
Ooh.
All
right. Everybody, Theo Wellington, thank you so much, Theo.
right. I said, apologize for being late. I've done a lot of driving today. That's
I'm glad you were, I was like too.
all right. So I'm always used to looking around here. All right. So this is a talk that's been somewhat modified, but I gave it a long time ago, back in 2012, when we had a transit of Venus. How many of you saw that? Yay.
I
For
did.
anybody
Also
who,
got our books autographed too.
yeah. And for all those who didn't see it, I'm sorry, because you'll never see it. Literally, this is the rarest transit. And when someone posted online, they said, what's the coolest thing you've ever seen in astronomy? I said, this, because you don't get the chance to see it very often. So, and do what?
Who signed the book?
The author.
I didn't see what
So this is Chasing Venus. And the cool thing about the expeditions to watch the transits of Venus back in the 17 and 1800s is that the people that did it left copious notes. I mean, they kept journals. So it's not just what somebody said they did, it's in their own words. And some of them have fantastic stories that this lady thoughtfully compiled. It's a really interesting read, and we're just going to hit some high points. I didn't know she was writing this book when I started this talk. And so it was kind of an interesting convergence when she came to Nashville to speak.
Oh,
Because the book was so much, and I appreciated it so much because she did a ton of work to transcribe a lot of the stuff, to go read all those notes. The stories are fantastic. And there's fun reasons why. I really appreciate history a whole lot more as I've gotten older than I did. You know, when you're younger, you just don't care. It's just,
when did she?
that's old people stuff, back in 2012.
Oh, man.
It was a long time ago. So, yeah. I love this quote, right? The improvement of geography and astronomy is the common concern of all polite nations. Thank you, Ben. All right, so I'm going to, can I get the Zoom? Can I make that small? Let's see. I am thoroughly lousy at, I want to window that so I can actually see my notes.
I got it. If you just hover.
Let's see, can you get? There we go. Okay, cool.
There you go.
There we go. All right, so I really like astronomy. Okay, it asks fun questions. It does fun things. Chemists have been trying to turn lead into gold for a long time, right? Turns out physicists can turn lead into gold, but they can only do it one atom at a time. Now, biology has tried to be controversial by exploring whether or not humans are close cousins with other primates, like, you know, apes, chimps, and monkeys. And I have no idea why we think that, right? But astronomy, on the other hand, asks some fun questions. How big is the universe? How many stars? How many galaxies? And unbelievably, we can actually get answers to some of those questions. So, for example, there's the WMAP, which was a microwave background measurements idea. Another project from the Europeans, the Planck. They don't agree precisely, but, you know, that's still amazing that we can say that the universe is right about that old. And what's interesting about being able to get those answers, we can't reach out and touch our stuff. We can't do experiments over and over again in the lab. We have to wait for nature to do the experiments in astronomy. We've been watching the skies since before recorded history. Astonishingly, people noted regular patterns in the sky. The yearly movement of the sun, the monthly phases of the moon, and those other 5 things that wander around. But they don't just wander anywhere, they wander in patterns that people learned to predict. So we started piling up stones to help us with our measurements. Our ancestors actually spent a lot of time piling up stones. A lot of time and effort. And still a lot of time and effort. The Smithsonian Planetarium in Nashville is a Stonehenge. The windows have particular astronomical alignments. So yeah, that's fun, right? So being curious people, we started right here on our own planet. How big is Earth, right? How far away is the sun? How do you measure distances like that without having a really long yardstick? Well, maybe we can't use stone piles for that, but a pretty old idea, geometry, can be put to use. Now, nowadays, we look to distant stars and we watch for a planet to go in front of that star and dip that light just ever so slightly. That's a planet transit. The history of transits of Venus across our sun is in part a history of our understanding of our world, the solar system, and our place in the universe. Venus, even before we knew what it was, had a special place for any observer, right? It's the 3rd brightest thing in the sky. It burns your eyes out just about when it's out. You don't have to ask, what planet is that? Well, that's Venus right there, because it's really bright. The Mayans in particular really liked Venus. This is from the Guy Otwell calendar, but when Venus moves through the sky, it makes exactly these 8 patterns. And that's a cool thing. They don't repeat exactly. And they almost part is what keeps us from seeing transits of Venus more often than we do. And of course, why didn't we see it a long time ago? People had to realize after they watched Venus for a while that it did indeed go pretty close to the sun. But naked eye, looking at the sun, even a long time ago, people figured out that was a really bad idea. So observing Venus in the daytime is a challenge. You can do it when the sun and Venus are separated pretty widely. The easiest thing to try is when Venus rises before the sun, go ahead and watch while the sun's rising and keep your eye on Venus, and you can see it after the sun's up. But it's a real challenge. So to see Venus going across the sun with just your bare eye, not really going to happen. So the Greeks got us started. Euclid did not invent geometry to torment students. It's a powerful mathematical tool that lets us measure our world and the universe. The Greeks started doing this without calculators or pencils. They watched ships disappear over the horizon and noticed that, hey, the ship goes away first and then finally the mast. They cleverly used shadows at different places on Earth to note that you could measure the roundness of the Earth. Christopher Columbus did not discover roundness. The Greeks knew it was round. And they actually ended up calculating fairly reasonable values for how big the Earth was. How to extend our understanding, they actually did kind of figure out how far away the moon was too. It wasn't exact, but it wasn't bad. For the next 2,000 years, we were trying to improve on this. And even today, geometry is still a tool of choice. Now, when we say transits, of course, we're not talking about this. I couldn't resist the joke. We're talking about this, when something passes in front of another object, in this case, Venus passing in front of the sun. And this is, I had just gotten a telescope in 2004. The transit was ending at sunrise, so this is not my best shot ever, but again, a rare event, it's happening. I'm out in the yard looking at it and hoping the neighbors don't think I'm looking at their house, right? So we reference things like that, a transit, and sometimes we don't call it a transit when it's just across the body, but we also talk about stars transiting the meridian, which is a totally imaginary line from north to south. So noon, by the way, is supposed to happen when the sun transits the meridian. And so that's why we have time zones and why we shouldn't have standard. Anyway, that's another talk. I hate these illustrations. They're in all of our textbooks. The planets do not line up like this. Okay. If it did, we'd have lots of transits. Instead, it actually looks a little bit more like this if you put them in a plane. And I can only note that one of those things is not like the others, okay? So, but we won't talk about that either. So people are a little off skew. You never get in 3 dimensions lineup of the planets. And because the planets orbit in planes slightly inclined to ours, you can only see that lineup when we hit the same, like when we come together at a node. And there's a really nice, let's see if I can get this guy to play. I'm gonna click it. No, come on, go back. Is there a play button on that? Ah, nope. That actually was really cute. It made Venus and the Earth go around until they finally come together. And that does not happen very often. So we spent a lot of time modeling the universe to figure out, because we could observe the planets. Now you want to predict. So you have to have a model. We had some things, Ptolemy did the first thing, and he had to put these cute little epicycles in to make things work. Tycho Brahe couldn't quite bring himself to kick Earth out of the middle. And Copernicus did, but he wanted to use perfect circles, which still didn't work. But that's okay. In the middle of all that, Galileo was more my kind of guy, not a theoretician. He's not going to make a perfect model. He's going to do observations. He took a telescope and looked at Venus. And the weird thing is, Venus shows phases just like the moon. The only way it can do that, go through every phase, is if it's between us and the sun. So he knew darned well that Copernicus was right about putting the sun in the middle and we all go around. Kepler was the one who actually used a lot of good data and said, hey, you don't want to use a circle, you want to use an ellipse and put the sun at one focus. So that works really, really well. And we finally had a good tool and some good math to predict where planets were going to be. So that aligned the positions of planets with both the TELUS data and it is. All right. So Kepler then produced tables of positions for the future, and he realized that both Mercury and Venus would transit the sun in the near future. Now we knew when to look, and we had a tool in the telescope how to look. And people got pretty clever pretty fast to know that, again, you don't put your eyeball to the telescope and look at the sun, but you can project the image. Now for Mercury, transits happen pretty often. Okay, transits the sun 13 or 14 times each century, which doesn't sound like a lot, but every couple of years you get a transit. Although Mercury's orbit is inclined 7 degrees to ours, it's closer to the sun, so it has a fairly large range over which it can be within that half-degree circle that the sun makes in the sky. But for Venus, that's different. Transits of Venus occur only 13 or 14 times every 1,000 years. Even though Venus's orbit is inclined by only 3.4 degrees, it almost always misses the sun. So that's kind of sad. Every so often, though, we have these pairs where it crosses the sun twice, 8 years apart, and then not again for a very long time. So if you want to stay in Nashville to see another transit of Venus, you're going to be waiting 101 years from this December. I don't expect to see that, but it'll be fun. So Kepler first predicted a transit of Mercury in 1607 and tried hard to see it. He realized later that what he'd seen were sunspots. His next chance was a prediction of a Mercury transit in November 1631, followed by a transit of Venus that December. Sadly, he died in 1630, so he didn't get to see that. Pierre Gassendi, an astronomer in Paris, took that and looked for it. And he did get to observe the transit of Mercury, even though it happened a few hours earlier than predicted. He wouldn't have seen it at all except for a telescope, because Mercury is really, really small. And if you're seeing is bad or anything is the least bit off, it's just really tiny. And that shocked people because we really didn't have a good idea. I mean, it's a dot in the sky. And when we could see it against the sun, people go, holy cow, that is small. But still, it was a good prediction and we got to see things. So that's cool. He tried to observe the predicted December 1631 Venus transit, but the transit sadly ended before the sun rose in Paris. Kepler's next predicted transit lay 100 years in the future. These are long-term projects. Sometimes science gets lucky. In England, a mostly self-educated, apparently mathematically gifted 20-year-old named Jeremiah Horrocks studied Kepler's tables and corrected them from his own observations. He correctly noted that the next inferior conjunction near the node would not be a near miss as Kepler had it, but a transit. The English weather broke just enough so that late in the afternoon of December the 4th, 1639, he was the first human being to witness a transit of Venus. That's just blows your mind. A friend of his, we think, also saw it. Same problem, and he was doing church services while he was literally running out of church, going back to his house, looking. It's an amazing story. And even better, he made observations. That's what makes it science. He did really careful drawings. It was very nice. And he shared that. His manuscript was titled Venus in Sole Visa, Venus seen in the sun. His observations allowed for better predictions of future transits of both Mercury and Venus. After thousands of years at looking at the brightest planet, we'd finally seen it crossing the sun. Kepler's work allowed us to scale the solar system in a relative way. We just called the distance from the Earth to Sun 1, right? Jupiter's 5, Saturn's 10. So what we need to know is how much is 1? How many miles, how many kilometers is that? Oh, well, 122 years till the next transit. Edmund Halley, who does not get nearly enough credit for being all the stuff he did, he was sent to St. Helena in the South Pacific in 1677 to watch a transit of Mercury. He managed to see the contacts, that moment when the planet starts to move on the sun, and then when it's fully on the sun. And he wanted to know how accurately could they time that. He understood, as a Scot named James Gregory had, that the geometry of a transit meant that if you're standing, let's say, in Northern Europe and you look, and somebody else is way down there at the bottom of Africa, that your view is going to be different because of parallax. And parallax is a really interesting thing. If you just stick your thumb with one eye open on Venus there and then switch to the other eye, it moves. It changes position because your two eyes are in a different spot. That's how your brain uses that information to do depth perception, which is also incredible. The software in your head does continuous geometry. we already knew that the nearer stars, if stars were way out there in space, we knew that if we looked at them from two sides of our orbit, we ought to see the nearer stars shift against the background of more distant stars. And we also knew that we couldn't measure it. It was so small that that challenge wasn't met until 1838. That's a different great story. So we have two observers both watching Venus cross the sun. And that's what, in a good world, that would look like. You'd have these two nice distinct paths so that you could see the difference and measure the angle now that the two observers are making between us and the sun and Venus. Now, the problem is that in real life, that angle is small. So that's what the actual difference in path is for widely separated observers. It's not a lot. So Halley said, you know what? Instead of actually trying to measure the path difference, it's also a different length. So if we really accurately time when Venus hits the sun and when it leaves the sun, that'll give us the path length, the chord, and we can use that information to figure out how far away the sun actually is. So that was a good idea. And the other thing he knew was that Mercury's dot was so small that it couldn't be accurately timed. So even though Mercury transits happen more often, we couldn't use them. We were gonna have to use Venus. Well, that's good, except for the problem of doesn't happen often. So yeah, there's Mercury on the left and Venus on the right. Whole lot easier to time, Mr. Big Guy. So the sad thing was, he also knew he wouldn't live to see it. So he wrote an essay admonishing the future generations that they needed to go and do this thing so that we could find out how far it actually was to the sun. It went on for some pages, but it's pretty cool that he did that. Recommend to the curious strenuously to apply them to the observation. And he laid out a whole campaign because he goes, if you just send two people out to two distant places, it'll be cloudy for both of them, right? You're going to have to send a lot of people to a lot of different places. And what do you know? When the next transit came, somebody said, hey, we ought to do this. Turned out that was a French guy. Well, then the English said, hey, we can't let the French get all the glory. We got to do it too. Then the Dutch said, hey, the French and the English are doing it. We can't let them have all the glory. Next thing you knew, 12 countries were participating in the first multinational science project, which is pretty fun. And, you know, competition is a good thing. So a lot of people stayed home somewhere in Europe. They could only see one side of the transit. They couldn't see both ingress and egress. So people went to other places as well. And the list of nations was pretty long. That was fun. Now, this was at a time when some of these countries were technically at war with each other. The scientific teams had letters that said, give these people safe passage. They're doing science. But if you're on a ship and the other guy is shooting his cannon, you're going to have to get pretty close for him to read that letter. So that didn't always work really, really well. The 7 Years' War was going on during the first one. And then the other problem is you're going to be going to weird places, okay? Sometimes the natives think you're up to something weird. You're setting up kind of funky equipment there. So it was an interesting thing to do. Science was a bit different then, right? We meet in our room with our, you know, smoking jackets on, and we're all very gentlemanly. And they worked in labs or in their spaces in the universities. They didn't go out in the field and stand in the grass and do stuff like we do. So they were going to have to get way, way, way out of their comfort zone. So a lot of them looked from Europe. Some travelers had good fortune and smooth voyages, some not. The Massachusetts Bay Colony financed an expedition, sending a Harvard professor to St. John's, Newfoundland. Harvard was, by that time, 1761, already over 100 years old. That was one of the first things they did when they settled Massachusetts was founded a university. So with apologies, just sit right back and you'll hear a tale of a fateful trip that started from this British port aboard His Majesty's ship. All right. And I had no idea when I put that in here that it would be apropos and is being used right now for some poor astronauts that are stranded on their 3-day trip. Two gentlemen with the names of Jeremiah Dixon and Charles Mason sailed out of Portsmouth, England on the HMS Seahorse and were promptly fired upon by a French ship. Damaged and with casualties, they had 11 dead and 37 wounded, they limped back to port. They had some discussion and they actually went to the Royal Society that had hired them and said, this is a terrible idea. We had no idea it was this dangerous. We do not want to do it. They said, you signed a contract. You either do it or we'll sue you. Well, when you put it like that, right? Time had been lost. They had to fix the ship. So they weren't going to make their original destination in Sumatra, but they went ashore in Cape Town and actually did a wonderful job of observing the transit from there. In recognition of their good work, they were sent to the colonies to survey borders. That Mason-Dixon. Okay. Interestingly, Mason also did a lot of work on lunar distance tables, which was a way to use the position of the moon, if you knew exactly where it should be in your sky, to figure out your longitude. If you didn't have a well-working clock, which wasn't easy to come by, that was actually used for about 100 years. It didn't work well, but it was better than nothing, so. Frenchman Alexander Guy Pingray, and I'm probably slaughtering his name, was sailing to the then French island of Rodriguez off the coast of Madagascar. On the same day that Mason and Dixon were attacked, his ship got chased by a number of British ships. The wind was with them and they escaped. But after the transit, he sat through not one, not two, but 3 shellings and sackings of the island by the British. He finally left on a ship bound for France, but caught by a British warship, he was captured and eventually ended up a prisoner of war. But the British were not uncivilized, so he shared time with the ship's doctor until they gave him back in a prisoner exchange. The good doctor had a stock of medicine on board, and so the quote was, "Liquor gives us the necessary strength for determining the distance of the earth from the sun." Not even kidding. The French really had some of the best stories. One gentleman went to Tobolsk in Siberia. He had good luck observing the transit, but he needed the army to protect him because the locals were just sure that they were some kind of weird magicians up to some mischief. Then there was this guy, whom we're just going to call Le Gentil, like everybody does. I can't imagine his story, but Odysseus had nothing on this guy. This guy had an epic, epic voyage. He left France on March the 26th, 1760, headed for Pondicherry, India, which possession of changed hands while he was on his way. One thing led to another, and he was at sea for the transit. He saw it, but he couldn't do measurements. He's on a pitching ship. He decided to stay in Mauritius and wait for 1769. He tried to get to Manila for that, ended up in Pondicherry and was clouded out. He said he couldn't get out of bed for a week. He was so disgusted. He'd waited all those years. So it's a great story, and there's a lot more in there that we don't have time for, but he traveled perhaps 70,000 miles and then getting home. 3 ships, dysentery. When he finally got home, he found out that he'd been declared dead. His estate was looted. He hired lawyers, sued to get some stuff back, went even more broke, married a wealthy woman, and had a great time telling the tale for the rest of his life. We don't do science like that anymore, do we?
Sure.
You know? 1769, the second of the pair. more competition, people going literally all over the world, the most famous voyage of which was Captain Cook observing the transit from Tahiti. They call it Point Venus, where he was. The 2012 transit was also visible from there, so I think Captain Cook might have been present, at least historically, to reprise his observations. That voyage is also an interesting story from relations with the natives along the way. See also using nails of your ship for currency. And he tried out sauerkraut as a scurvy cure. Turns out it works. Not as popular as the limes, though. And sometimes, just because you weren't encountering cannon fire didn't make it safe. The same person who was in Siberia went to Baja, California. Okay, it's sunny and warm in Baja. That's good. Bad. A fever went through the crew. So only one person from that expedition made it back to France, but they had excellent data. They got the data back. You thought space travel was dangerous. All right. There are surprising connections as well. Although we were still a British colony, there were quite a few stations in the US that looked. John Winthrop of Harvard had looked at that 1761 from Newfoundland. He wanted to look at 1769 from Harvard, but a fire had destroyed the telescopes. So he asked his friend, Benjamin Franklin, to order a new telescope from London's James Short. Franklin was in London. The order was complicated by the fact that Short died before it was ready. So Franklin really had to work to get the instruments finished and sent back. Franklin was well aware of the transit and of its importance. And we wanted to say, hi, we're Americans. We're not just a bunch of rubes out here. We can do science too. So he published information in Poor Richard's Almanac for transits of Mercury. So these are estimates. Was it worth it? Previous estimates of the astronomical unit were hardly better than educated guesses. The distances there are in Earth radii, and the modern value would be 23,455. Halley was hoping for a precision of 1 in 500. That was what his estimate was based on geometry and how accurately maybe you could time it. Unfortunately, the timing thing turned out to be really, really, really hard because of a particularly weird effect called the black drop effect. When you get a black thing on the edge of a very bright thing, you get this little connection happen. It's really hard to time exactly when does Venus touch the edge of the sun. And this is true for any dark objects. You can actually do it with your finger and see the same effect. So it limited what we could do. And there's a modern, even in modern pictures, it's not just a purely visual thing. It's just a thing. So the first transit pair results, Jerome Lalande from the French observatory reduced the data from all the observers. They were all really cool and shared their data, put it all in one big happy pool, and got this value, which isn't too bad, right? There's the current defined value. There was a lot of scatter in the data. It wasn't as good as they'd hoped for. So you do an experiment once, you want to do it better. All right, you're going to have to wait. And we did. 1874 and 1882. All right. It was easier to travel by then. Better equipment was available. And there was this great new tool, photography. We could more accurately measure longitude. We had good clocks. Weather, of course, is still the same. But it was hoped that with all this great new stuff, we could really pin that distance down. And so people piled on again. It was really fun. All the places people went to do this. Countries took advantage of their colonial territories. The Netherlands had 15 ships moored at points in the Dutch East Indies. 5 British expeditions. All over the place. All right. And the fun thing was even Egypt contributed observations from Cairo. So as many people as possibly could got in on this. The United States was now an independent country and ready to take its place. We even had a U.S. Transit of Venus Commission. The first part of the transit was not visible from the US or Western Europe, so we joined all the expeditions abroad. Now keep in mind, these are only the fourth and fifth ever observed by human beings. So in many ways, the list of individuals that were involved is a list of who's who in astronomy at the time. Everybody wanted to do this cool thing. Simon Newcomb, who was at the Naval Observatory, right? I don't ever want to be vice president, but I would love to live at the Naval Observatory, yes. He headed up our commission and said, you know, if we're going to be an important country, we need to do this. So they asked for $3,000 from Congress initially. They got $2,000. That's not bad. They got a few things. The next year they got $50,000, which would be $937,000 in current money. And finally, they asked for $100,000 and got it, and permission from the Navy to use 2 ships. Cool. And yeah, just then we were starting to use photography. This is, I think, the Orion Nebula first shot. And so if you complain about your first photograph, it's probably better than this, right? Dr. Henry Draper was asked to help plan how to do this. He was not a professional. He was a doctor of medicine. But he had money, and so he had a telescope. And he'd gotten pretty good with that. And I made a little bit of fun of this because it reminded me of somebody that's one of our club members who had a really nice observatory out west of town. He wasn't a doctor, he was a lawyer, but the same idea. You've got some money and some time, and you can do fun stuff. Henry Draper also did a catalog of stellar spectra. That's why a lot of stars have the name HD and a number. That's where it's from. He did a bunch of stars until his death, and then his widow funded the continuation of his work at Harvard. So yeah, amateurs can make contributions. So thus equipped and trained, American teams went to Vladivostok, Peking, and Nagasaki, Tasmania, New Zealand, Chatham Island, just off New Zealand, and Kerguelen Island in the Southern Hemisphere. Now that is a remote dot. And when I say remote, I don't mean remote like West Texas. There it is on Google Maps. So it's got a nice little glacier on the one side. That little input there, that's called Observatory Bay because people set up their telescopes there. We'll back off a little bit more, and it's still kind of lonely. We're going to back off even more. And I mean, this is a lonely place. We didn't have airplanes yet, so this was a sailing voyage. And this was a December transit, so possibly lovely weather as well. The southern seas are known for defining the term high seas. So they had a lot of fun down there. They said they had rain and snow most days of the year. Winds of 150 kilometers per hour are common. Wave heights of 12 to 15 meters are common. But the seas are generally ice-free. The Navy lieutenant commander in charge said that in our 4-month stay, we had 75 days of rain or snow and but 11 days of clear weather, some of which would hardly be called clear at home. But they saw the transit. And the posts where they set up the telescopes are still there, because why not? So they got good observations, good photographs. Yay. All right. And on the whole, a lot of good observations were made, and photography really, really helped. Come 1882, look at where you can see the whole eclipse in white. USA, USA. So that was our eclipse. People came to America to watch it. So we got to play host. That was really fun. Look at how many people. Wow. So that was a lot of fun. Lots of people came. And of course, we needed to do both the northern and southern hemisphere to get that separation. And weather, of course, is weather. Somebody in Dublin that was looking said, Still, to have even seen a part is an event to remember for a lifetime. And that's true. This was the era of explosion of telescopes too, mostly big refractors. Lick Observatory was under construction. The US also sent lots of expeditions abroad. Alvin Clark made a lot of the telescopes for that. And let's see if I can get this one. Will this one play? Let's see if it will. Hello. It's the hardest thing in the world is to get videos, but they had a nice set of plates that were discovered at Lick Observatory, and somebody ran them all together, made a little movie of Venus crossing the sun. And that Lick wasn't finished, so they had to walk up the hill with their stuff. If you've ever been to Lick, that's not a trivial thing to do. It's even the road that they've paved is nasty. And this is fun because Nashville, Vanderbilt Observatory had 2 observers. Olin Landreth in the dome, and on the grounds, Edward Emerson Barnard with a 5-inch refractor. Clouds were a problem. There's a lot of groundwork also to do before the transit. You have to really accurately figure out where you are. You want to make sure your clocks are good. Now, being on home turf is a huge advantage, right? You don't have to be on some windswept island trying to set your clocks. And then, I love this. Time signals were struck on the fire alarm bells of the city. That's fun. I don't know if we can get them to do that for some other astronomical event.
Some other historical thing about that. For one of the other transit, they shot a cannon from the railroad town from Union Station.
Wow.
Union Station, but the railroad terminus.
Yeah. So, nice note here about E.E. Barnard, and he did a good job, right? So at the end, he got appointed to a fellowship in astronomy. He had not graduated from any university, but he did good work. My favorite observer is still Mariah Mitchell, observing from Vassar, first woman to work as a professional astronomer in the US. She worked at the US Nautical Almanac office, computing the position of Venus. What do you call that job? You're doing computations. You are a computer. All right, so after the 1882 transit, Simon Newcomb at the Naval Observatory combined the data from all 4 of now the observed transits and came up with that value there, 149.59 plus or minus 0.31 million. And there's the currently accepted value. So they've done good with just geometry. Literally stone knives and bearskins, right? Now, some people go, well, we can do it better. I mean, yes, we can do it better today. We can do geometry well enough to pilot spacecraft across vast distances and actually get where we're going. But that is pretty good for really not much more than human observation and plain geometry. And hey, Philip Sousa wrote a march about it. So that's fun. It was actually thought to be lost for a long time until somebody cleaned out a closet somewhere in the Smithsonian and found it. Now, of course, we do other fun stuff. We can actually measure the dip of light from planets going in front of other stars. This was not discussed when I was an undergraduate. It was basically deemed impossible because we didn't have good stuff. We got better stuff now. So now we're finding planets. We had a spacecraft stare real hard at the sky. The transit of Venus was actually kind of used as a dry run for some of this because it dims the sunlight by 0.001 magnitude. So Venus is an Earth-sized planet crossing a sun-like star. So that was a good test of can we detect that level of dip. Scientists also watched a transit of Mercury, and you know what? We can't see that. It's too small, and we're not going to see it around somebody else's star. So that helped to put a limit on what we could expect to see. Kepler, to date, I think they have We're over 2,700 candidate planets. There they all were. Funnily enough, nobody really looks like Kansas yet, but we're still working on that. Besides raw photometry, some other clever tricks have been tried. They looked at sunlight reflected by the moon to search not just for dimming, but to see how much, because the moon is reflecting sunlight. So that's the solar spectra. And then when Venus puts its atmosphere in the way, you're going to see some different stuff. So that's sort of a clear secondary way of looking for the imprint of a planet's atmosphere on stellar spectra. And I would have said, oh, no way. But yeah, we can actually do that. So that's kind of fun too. Let's see. I think this is the current thing. Well, it was 2004. The Eastern US, we got to see sunrise, but Europe had a great view. Sidewalk astronomy had a great time. And yeah, look at all those people looking at the sun and not going blind. So Hubble actually looked at the moon as a mirror because we never, ever, ever even think about pointing Hubble at the sun, right? Not even close. But they can point it at the moon, so it did some reflection work. And we did a couple of other clever experiments with some of our other spacecraft as well. It was kind of fun. STO's pictures. We actually even did some work with Cassini, looking from way out there at Saturn. Now, the interesting thing is, of course, Cassini's at Saturn, so it doesn't see the transit of Venus when we see it. It happened on December 21st, 2012 for the spacecraft, kind of like close to the end of the Mayan calendar thing. Now, while we didn't see the whole transit here in the US, it didn't end by sunset. We had a BSAS member who went all the way to Alaska. Spencer Buckner was up in Alaska for that. And sadly, it was cloudy. Dadgummit. The great thing about some of these is that these are things that are accessible to everybody, right? You didn't really need any special equipment. There's no charge for watching the planets as they dance in the sky. Rare events that get significant press coverage are fun, and I hate the supermoon junk. Don't ever ask me about that because I will rant for a long time. But I do like things that happen before bedtime. So watching Venus, and it doesn't take a really powerful telescope, just, get a good tight focus to see the phases, which is really cool. I had a call from Leland, well, not a call, he sent me a text. Leland Statham at News Channel 5, he said that the guys with the Skycam took a picture this morning. It looks like the moon, but it's way too small to be the moon. What did they do? And turned out they had seen a crescent Venus. That camera under that helicopter is darn good. I hate to think what it cost. This was somewhere on that, there is a dot. That's my son's t-shirt I was projecting it on. I woke up all my kids for this, so they had to go see it. And they were pretty good about it. In 2012, we had like 10 solar telescopes outside the Science Center. We had lines until the sun went down. This was one of the largest public events that we'd ever had at the Science Center. We even had a guy who came from I don't know, North or South Carolina, because it was going to be cloudy there. He said, can I look at it from the Adventure Science Center? We said, sure, if you don't mind sharing. And he had a blast. He really did. The 7th transit ever seen in all of recorded history. And, I don't tell people to do things like this, but I'm standing there at the end of the day. The sun is setting. The solar glasses are nice, but I went in the building, so now I can put UV filtering glass between me and the sun. The sun's really low and really red. And you bet I looked at Venus on the sun. You're darn right. That capped off the day for me. The rarest eclipse. We're still using geometry. The satellite's doing nothing but geometry to accurately measure the position of what they're hoping 1 billion stars. That's crazy stuff, but it's fun, and it's great that we can do that stuff. Our instrumentation has gotten really, really, really good. So, where are you gonna be? Or if you want to be here, there we go. And one last word. Syzygy, because it's a great Scrabble word. No, there are not 3 Ys. Okay, if you're a Scrabble fan, you know that, but you can use the blank for that, okay? And of course, I could use Photoshop for that. But it's a great word. It means any 3-body lineup. So if you ever want to impress your friends, you can use that word. All right. Anyway, that's really it. I just really thought that was the coolest thing I'd ever seen. I really recommend the book because the history and all these stories of these guys going out into the wild and all the things that happened to them, the adjustments they had to make, and yet they really wanted to do it that badly that they're slogging their way out there, setting up instruments, accurately figuring out where they are, what time it is. It's really an amazing story. And they probably didn't get paid nearly what it was worth. But how our drive for knowing these things and hey, we can cleverly figure it out. It's just a fascinating tale. So I hope you enjoyed that. Thanks. Yeah, so
The transits and you're showing the graph.
yeah.
The graphs, and I may not be doing this right, seem to come down like this and kind of make a U and then come back up. Why don't they just go and then bucket out? Does that make, did I make?
Yeah.
Make sense?
It doesn't have a sharp edge because if you look at us, even the sun, you get this big dimming toward like because they're round. So the amount of light you get from the edge of the sun isn't the same as from the middle. And so it looks
Well, I
it's gonna
understand
tail
that
off.
initially.
Yeah.
Yeah, I can see a little.
And also those are
In my little Scottish mind, it
it should go
straight
like
down.
that. And those are pretty idealized graphs too. Go look at some of the Kepler data. It don't look like that. What it looks like is you got this squiggly line, and then you can imagine maybe there's some dipping there and some more like that. It's fun to look at. That was another citizen science project, by the way. You could go comb through the Kepler data and look for transits yourself because they literally had so much data they couldn't do it all themselves. And you can't teach a computer. They're not good at pattern matching loosely, right? Where you have a little bit of swag in that pattern that you're trying to match. I can imagine that it's a transit, and then somebody will have to go look at it again to verify it. But anyway, yeah, I think they're just trying to make an idealized sort of thing like that, and that's not what it looks like. Art. We'll call that art, not science. But that's a good question, because yeah. And of course, if the planet has an atmosphere, some other, that could be fun too. And what was the first thing, when I was in school back in the day, right? When I was your, we assumed that we have a solar system with rocky planets, asteroid belt, gas giants. Doesn't everybody's solar system look like that? Well, no, turns out not. So the first exoplanet we find is some Jupiter going around its star in like a few days. That's crazy. I call those knuckle draggers, especially when it gets to be less than a day, because you could literally almost reach out your hand and drag your knuckles through the star. I mean, Mercury takes 88 days, and it's close enough, right? You talk about going around your star in a day, you're close. You are just close. That's all there is to it.
You're almost inside.
Yeah, I mean, and so hot probably doesn't accurately describe it.
What kind of crap? I blame relativity.
And so, over time, we found out that there are lots of ways to construct a solar system or a system of planets, and pretty much none of them exactly look like ours. And that the most common kind of planet, at least that we're finding, and we may have selection effects, are super Earths or mini Neptunes, which is something we don't even have in our solar system yet. We're still looking out there in the Kuiper belt for Well, it's gonna be way out there, but, so it's, you know, it's really fun. When you look, you find things, not always what you expect. But yeah, good, clean fun. And if, you know, I don't know, was it here or was it when the web lady came last month and she had some of her spectra from the web? Oh, those are, I mean, you look and they go, oh, that's a line from this element. And you're looking going, okay, because it's a lot of squiggly lines.
Any other questions? Good deal. Well, thank you, Theo.
You're welcome.
For a fantastic
May
talk.
may I make one other observation? Because you
Turn a line.
touched on it
Mhm.
when you were talking about people from all over
Yeah.
the world, many different countries, but one of the things that really struck me when I read that book is that it was the very first time that there was worldwide cooperation amongst all of the scientists, because in the past, they all kept their data very protected, and they wanted to be the first to do this and the first to do that. And when Haley or Holly said, hey, there's going to be this transit, but the only way we can figure out the distance is if we cooperate and we share this data.
Yep.
And everybody like, what? Share data with our enemies? And yet
We did.
they realized, oh, yeah, so that bode well for not only science, but I think for humanity. Maybe there's still hope for us.
Yeah. You know, if we really, really, really want to do something and it takes people, you know, people from all over to do it, we can. We can, you know, do stuff.
What's a few cannonballs?
You know? Yeah, that would not have been fun. I think the ship was dismasted the first tryout. And I mean, if that happened to you, I'd be going, nope, nope, nope. But yeah, they literally told them they would bankrupt them if they didn't go. Oh, man.
Well, they wanted to go in the first place. The additional incentives.
Yeah.
Plus,
Yeah.
they had to be crazy.
But they really did they were good at doing that sort of measurement. And it again takes a certain patience, but you can imagine what the locals would think. You show up somewhere and you have to, you know, all they had were pendulum clocks, right? And to set it correctly and keep it working and be accurate. Oh my gosh. It was just, and then hope for the weather. And
Along those lines, can I throw in another anecdote?
Yeah.
Not only natives thinking you're crazy, but I can't remember which expedition, but I guess it'd have to be the English or the French, but they were at war with the Portuguese and the Spaniards. And they were on their way down to the Southern Pacific, but had to stop in Brazil to resupply, get water. Well, that was a Portuguese possession and the enemy, but they thought, well, we'll explain that what we're doing
we're doing science.
and they'll let us. And the viceroy in Brazil said, well, what the hell are y'all doing here? And they proceeded to tell him, well, we're going to measure the transit of Venus across the sun. And he said, that's the most ridiculous thing. You're idiots. You think I can fall for that? You're spies. And threw him in jail. And I don't remember how they got out, but you know, just stuff like that. If they made up some really crazy story, maybe they could have gotten out, but they were telling the truth. Say, oh, we're going to measure the transit of Venus. And the guy just thought this was such a cockamamie, made up thing. Obviously they're spies.
Yep.
And that book is full of scores of stories like that.
The one French guy, and this seems very, very French, everywhere they went along the way, he was rating the women. Just saying. They were good notes that they did.
Well, awesome. Well, thank you very much, Theo.
Yeah.
Good talk.
Yeah.
And for those playing at home, the book is Chasing Venus.
Yep,
Uh,
Chasing Venus, the race to measure the heavens.
Cool.
And yeah, it's a lot of fun. It's a good fun read.
All right. Well, with that, I think we'll conclude tonight's meeting and this month's member meeting. Thank you everybody for coming. Thank you everybody that showed up online. Appreciate it on Zoom. Again, next month we'll have a speaker on Zoom, so it should be a fun talk as well. And with that, have a safe month and get out there and observe the moon.
Yeah.
Yeah. Yeah. Yeah. Oh, Steve.
I'm not sure if you're gonna say anything or not, but just let everybody know, especially for your new members here, after the meeting, the main astronomer here, Billy Keats, will open up the scope upstairs.
Oh.
Now it is cloudy out there, so we probably don't have much of a view, but if anybody would like to go up and see the scope, ask some questions, you're welcome.
Cool. Awesome.
And say nice things because Billy refurbished the scope and it looks beautiful.
Yeah.
It really does.
Turtle wax.
Off brass, who does that?
All right. Well, thank you, everybody. Have a good night.
So there's been a weird discussion. Should we get some more?
Yes, I was.